Okay, we're going to start this morning here going over what to do when you have even powers for sines and cosines. I titled this Reducing Powers because you actually do this in a trig course. You reduce your powers from power 2 to power 1 for sines and cosines. And the reason you do that is because one day you'll take this calculus course and you're going to have to reduce powers. So really I would like to say that the essence of what we're going to do with this video here, like I've mentioned in class, is reduce these powers. So these are going to be some extra examples that we go over. And in order to do that, we're going to use our half angle identities. And in this case, since we have cosine squared, we're going to have to replace cosine squared here with 1/2 1 plus cosine 2x here, and that will give me an integral that has a power that's reduced. You went from the second power to the first power, and this is what we're talking about here. It's this cosine 2x which is now power 1. So using your typical properties of integration, we can pull out a constant, and we can now use the integral of a sum being sum of integrals. You're now able to integrate this function here. So here's the original function. It's cosine squared. Oops, go back. Cosine squared x, using again your half angle identity for cosine squared. This is now reduced to power 1 where we can integrate. Okay, let's remember here a couple of things here. This integral here is just going to be x. And so maybe I'll just change the color on this one. And we can go maybe to red. Let's try this out today. Let's see how this works. That integral is x. What you're going to have to integrate now is over here. And you're going to have to use u sub, where u here is going to be 2x. So you're going to focus here now on this u substitution here for 2x. As we mentioned in class, you've had this in Calculus 1. You should be able to do u sub. There's a video on u sub as well. I'll go through a few of these here for us for u sub. I won't go over every detail, but we'll kind of review a bit. U substitution. Remember what this means now is, and let's kind of change some of these colors here, I guess. We're going to say u here is actually 2x, which means my du is 2dx. And I can solve here for dx, and I'll get, looks like du over 2. So this particular integral here of cosine 2x dx with all the detail becomes the integral of cosine u du over 2. And I can now pull out my constant of 1/2 here. And I got cosine u du. And here's that constant we're talking about. We're going to pull that out. And I have to now remember what's the integral of cosine, or what's the antiderivative here. So this here is going to be sine. So I'm going to replace this integral now with sine u. So what I really have is 1/2 sine u. And u, let's not forget, over here is 2x. So I'm going to replace this u with a 2x. And now I have this 1/2 sine 2x here. Okay, this is what we're going to use. Now go back over here to the beginning. This here, this portion is what we're talking about. This will be 1/2 sine 2x. Okay, so all together, don't forget, I have 1/2 here. On the left side, I have this 1/2 x. And let's kind of go through this. Maybe let's put it all the way down over here. So I'm going to have my 1/2 x brought down originally over here. Okay, so people know that. And then this is going to be plus 1/2 times that 1/2 sine 2x. And don't forget at the very end, we're going to add our constant. So we have this 1/2 x plus 1/4 sine 2x plus c. So what we essentially did was we reduced the powers here for cosine squared. Just reduce that power using your half angle identity. It's now going to be an integral here. There we go. Without the power 2. And this is by properties of integration and substitution. This is the process that we use to integrate cosine squared. Now, in class, I reminded you again, we could do the same thing for sine squared. The same exact thing happens for sine squared. Now, I did this one in class, so I won't do it here. However, let's go back and take a look and see what kind of identity we'd use for sine squared, because it's different. Here's the difference between the two. For cosine squared, you have addition. For sine squared, you have subtraction. So when I now integrate sine squared, we get to replace this sine squared with 1/2 1 minus cosine of what? That 2x. So this integral becomes 1/2 1 minus cosine 2x dx. And ultimately, what's going to happen with this particular integral as you go through the process, because you notice they both involve, well, let's go back here. We'll put it in blue. We reduce this power to 1. The only difference is the sign that's here. So at the end of the day, I can look above my answer, and by the same exact process, properties of integration, and then u sub, we'll end up with 1/2 x minus 1/4 sine 2x plus c here. Now let's get that sign a little better. And it's the exact same process above. So I won't go through that in detail. You guys can try that out, or we actually had probably one of those here in lecture. What I'm going to do here for reminding people here, we're going to kick this up a power, and we're going to do another exercise here in reducing our powers so that we can integrate. If we have the integral now, and let's just use sine squared. Actually, we're going to do sine to the 4th power. And again, notice this power here. Okay, that's a power that is a nice even power. And what we do here is reduce these powers all the way down to a single sine or cosine. We're going to reduce these powers so that we can integrate. And so the title again was Reducing Powers, and this is typical in a trig course. So I'm going to write down the kind of work we do in a trig class to reduce the powers. And so you have sine to the 4th here, and that's what we want to focus on. We're going to reduce the power. And how we do that is to write sine to the 4th as sine squared times sine squared. And again, we're going to use a half angle identity for each of the sine squared. So this will be 1 minus cosine 2x, 1/2, 1 minus cosine of another 2x. So algebraically speaking here, the order in which you multiply does not matter. So my 1/2 times away 1/2 becomes 1/4. And now I just have 1 minus cosine 2x times another 1 minus cosine 2x. Again, we use FOIL. So when we go through and we multiply with FOIL here, I'll have 1/4, 1 minus, I'll have 2 cosine 2x's plus cosine squared 2x here. And this is all from FOIL. First term, outer term, inner term, last. So remember, you're multiplying that first terms here. And then if we change this, the outer terms, and then the inner terms, followed by the last terms. And this doesn't look like it's working out as nice as I wanted. Anyway, those are the last terms. So let's get rid of these here. Okay, let's put some of that back. Okay, you guys got the picture. This is simply FOIL. So now what I'm going to do here is let's distribute. So we'll have 1/4 minus 1/4 times 2 gives me 1/2. And I'll multiply the last term here by 1/4. So we're going to distribute. Maybe it works better this morning if we just do that little lines here. Okay, that's the distributive property. And you're going to notice again, you have with you a power 2. It's an even power, it's power 2. Well, we're going to reduce this power by using, again, the appropriate identity. So I'm going to replace this cosine double x with 1/2 1. Now this is plus for cosine. And we're going to have to double 2x. So here's what you really want to pay attention to. Here's what you want to notice is that doubling 2x gives you now 4x. So that's a 4x. Altogether, we have 1/4 minus 1/2 cosine 2x plus 1/4 times 1/2. 1 plus cosine 4x. So we're just going to have to do some arithmetic here and simplify what we have. 1/2 minus 1/2 cosine 2x plus 1/8. What I'm going to do here, I'm going to do a little bit of multiply my fractions, and I'm going to distribute, meaning I have 1/8 plus 1/8 cosine of 4x. Notice these two terms, my 1/4 and my 1/8, I can add. And what you've been noticing in class, what I like to do at this point when I add these terms, I like to remember that how do you actually add fractions? You have to have the same denominator. So I'm going to multiply this top by 2, this bottom by 2. Now what that does for me is I now get 1/8 minus 1/2 cosine 2x. I'm sorry, that's 2/8 plus 1/8 plus 1/8 cosine of that 4x. 2/8 and 1/8 gives me a nice 3/8. So I got 3/8 here minus 1/2 cosine 2x plus 1/8 cosine 4x. So this here is what we're going to use now. Let's leave it there. To integrate. So let's go back here. You're going to try to integrate sine of the 4th power. This sine of the 4th that we just were given is going to be replaced with what you see here. Okay? That is reducing your power for sine being of the 4th power now to single powers. Okay, so you have single powers here for cosine. There's no power 2, 3, or whatever. This is just single powers. We reduce these powers. Now you're going to integrate. So we have to integrate here dx. And by properties of integrals, we got, let's kind of try to do the best we can to fit it here. Properties of integrals, we get 3/8, we're going to integrate dx, minus 1/2 integral cosine 2x dx plus the integral of 1, oops, let's go back, 1/8. Let's be consistent with those properties. Integral cosine 4x dx. So I want to point out to you, let's try to find a nice highlight color. Maybe we'll do, try these grays. This is an integral. This is another integral. Here's the third integral. We're going to integrate these three. Now notice here, the first one is somewhat easy. This I could replace with just x. That's the integral of dx. The second and the third integral, remember, you're going to have to again use u substitution. And in this case, u will be 2x. And yes, that means du becomes 2 dx. U here, by u substitution, is going to be that 4x. And in this case, du becomes 4 dx. Okay, so let's see what happens now. We're going to have 3/8 x here minus 1/2. Now don't forget what happens here. By u sub, this integral here of cosine 2x is going to become 1/2 sine 2x. Plus 1/8 here, and this integral becomes 1/4 sine 4x. And yes, don't forget to add that constant. So we did u sub for the last two integrals. We're going to end up with now 3/8 x minus 1/4 sine 2x plus 1/32 sine 4x plus some constant c. And this is here what we end up with to reduce the powers from 4 down to single powers here. Okay, this is the process. The main work here is actually from trigonometry. And so we did the power 4 here. Obviously, again, if you had cosine of the fourth power, you're going to use the identity that has sum here. So this is kind of, again, this is really a trig kind of problem, but it gives us a nice sort of simple integrals at the end here, where this is done just by definition, really. And here we have u sub, and here we have another by u sub. So those fundamentals from Calculus 1 are really at play here. Okay, so really a Calculus 1 question combined with 241, reducing powers. Let's look at another example here. I guess we're at what? We did sine of the fourth. I want to kind of illustrate something that's kind of similar. You got sine squared, and maybe I'll put that argument x cosine squared x here, dx. I want to say to you guys, let's try to do this kind of integration. And I'm going to show you the similar sort of idea behind the one we just did in the past here, fourth power, and how it's very similar to what you have here. And I want to point out to you again that you have power 2, and that they are actually even powers. So we're going to reduce our powers in the same way we did from Math 241. It's just that sine squared gets replaced now by the half angle identity of 1 minus cosine 2x. And cosine squared gets replaced by 1/2 1 plus cosine 2x. Okay, so this first sine squared, and this is cosine squared, we use again the half angle identities for them. But algebraically speaking, and so all the work here is going to be really algebra. And again, we start with taking, I'll do the same kind of procedure. We want to reduce the powers for sine squared, cosine squared, Okay, let's get back our computer here. All right, we're going to reduce these powers. But look at the algebra. I'll get 1/4, 1 minus cosine 2x, 1 plus cosine 2x. When you use FOIL now here, because you got plus and minus, your O and I terms go away. So by FOIL, we have 1/4, 1 minus cosine squared 2x. There are no O and I terms. When I distribute now, I'll get 1/4 minus 1/4 cosine squared 2x. And so as you guys can see, again, the pattern's going to be now, let's maybe put this one in red. This cosine squared gets replaced with 1 plus cosine. Let's remember, we have to double this 2x angle. Doubling 2x gives you now 4x. So altogether, let's see what this becomes. We have 1/4 minus the original 1/4 constant times that 1/2, 1 plus cosine 4x. And so doing what we did before, I'm going to here distribute and multiply, meaning here this is really 1/8, the constant. And so when I distribute this, I get 1/8 minus 1/8 cosine 4x. So ladies and gentlemen, take a look here that this is really going to be the integral of what you see now. Let's go back a bit. Before we integrate, what do you guys notice? We can combine like terms here. So let's do the same as what we did before. This is 2 and this is 2. What that gives me is 2/8 again, minus 1/8, minus 1/8 cosine of that 4x. So simplifying, or actually adding my fractions, subtracting, 1/8 cosine 4x. Now we get to what? We get to integrate here. And by properties of integration, you get 1/8 integral dx minus 1/8 integral cosine 4x dx. So again, one of these integrals, or I should say both, are calculus 1-ish. U is going to be 4x because we're going to do u sub for this integral. U is 4x, and again that means here that du is 4 dx. You can solve for dx. You could do u sub. This is the integral here that we're going to need to integrate. That's the one you do by u sub. Okay. So I'll end up with 1/8 x minus 1/8 times 1/4 sine 4x plus c. So when we do the arithmetic now, 1/8 minus 1/32 sine 4x plus my constant. There you go. So notice, at least in terms of structure of reducing the power, this problem, sine squared, cosine squared, where you have these even powers, behaves very similar to the prior one, which is going to be sine to the 4th power, in that when you reduce the powers by the half-angle identities, it just becomes very similar algebra. You just differ by a sign here. And that kind of brings me to kind of a point I want to make. Well, I think I might do one more just to let you guys know we could continue this process. let's kick it up a notch. Okay, and this is going to kick this up a notch. If I say, let's integrate now, maybe, let's really kick it up. Sine to the 6th power, x, dx. So you could kind of see how this works now, based on the ones we had in class and based on what we're doing now, that this power here is again even. These are even powers. We're going to, as a result of even powers, right, we're going to reduce the powers, and that's the exercise. So back from trig, I know I give my students examples of sine to the 6th, cosine to the 6th, and you're going to see the next sort of variation of this idea. We're going to use again the same half-angle identities, but we're going to have to write sine to the 6th first as 3 sine squareds. And every sine squared will have the half-angle identity, 1/2 1. And this time it's going to be minus, so I'm kind of alternating, I guess. Minus cosine 2x times another half, 1 minus your cosine 2x times a 1/2 1 minus cosine 2x. Again, reduce the powers. And maybe it'd be interesting to say, let's try that in red. Reduce the what? The power. Okay, let's do some algebra here. So I want to point out that I'm going to take my constants. I like multiplying the constants and keeping them on the outside there. So that'll give me a nice 1/8. And I do have 1 minus cosine 2x, 1 minus cosine 2x, 1 minus cosine 2x. You're going to use now FOIL. This is just algebra. You're going to use FOIL here, and then you're going to ultimately use FOIL again. So I want to point that out from the beginning. So let's just get started on this, and we're going to have to be careful with the signs because they're minus, and if it was cosine to the 6th power, then it would be a little bit easier in the sense that you have the addition signs here, but this is sine. So let's try this out, and I'll have 1/8 now. 1 minus 2 cosine 2x plus cosine squared 2x. Okay? And don't forget we got 1 minus cosine of 2x here. And so we're going to have to be very careful now with how we do our FOIL. And this is not even FOIL anymore. We should call it, and I know I call it FOIL-ish. Because I'm going to have to take all my terms. I'm going to have to take this 1 and multiply it to every term, all 3. I'm going to take this minus cosine. I have to multiply it to all 3 terms. So it's not strictly FOIL. It's kind of FOIL-ish. So let's be sort of systemic about what we're doing. We want to be careful here. So what I'm going to do here is, because of space, we're going to have to take 2 lines here now. So that's going to be 1/2 here. And notice this 1 we'll start with, it's going to get multiplied to all 3 terms. Now let me get rid of these kind of things because they're a little bit distracting. And 1 is going to multiply by 1. Remember, 1 times anything is itself. So in some ways, we just copy the first 3 terms down. And that's multiplying everything by 1. So let's erase this. Now let's multiply everything here by the, careful to include the sign, a minus cosine 2x. And I'm going to try to strategically place these answers below. Let me show you what I'm talking about. This minus cosine 2x gets multiplied to the 1. And so that's going to give me a minus cosine 2x. I have to multiply it by the negative 2 now here. So that's going to be minus and minus makes this a plus. And that'll be now plus 2 cosine squared 2x. Let's double check. And then negative times a positive gives me a minus cosine cube 2x here. So when I simplify this, I get 1/8 1 minus 3 cosine 2x plus 3 cosine squared 2x minus cosine cube 2x. And as you guys can see, going from power 6 now, we have this even power. Reducing these powers from power 6 now, we're down to power 1, down to a power 2, and a power 3. So we're going to have to reduce not the power 1, we're going to have to reduce cosine squared, and see what we do with cosine cube here. So we have more work to do. This is more algebra. Now, what I want to point out to you, there's kind of an obvious. I get to replace this cosine squared now with, as you might guess, here's my cosine squared. I have to replace this with 1/2 1. Now be careful, because it's cosine squared, it's plus cosine double the angle of 2x, which gives you 4x. So I'm going to have to multiply that original 3 out here by that term. And then I'm going to say to you guys, take a look, and this cosine cube now. You have to deal with this cube power. You're going to write that cosine cube as cosine, let's say cosine x, and then cosine squared 2x. And you might notice again, boy, I have a cosine squared here. That cosine squared gets replaced as well with a 1/2 1 plus cosine 4x. So notice here, there's going to be some more algebra, and we have to be very careful here. So I'm going to go through the algebra here and be careful. So what I think is good at times for me when I see this kind of problem is I'm aware already what I have to replace that cosine squared with, and I'll just leave it this way. What I like to do is I like to distribute the 1/8. That helps get that 1/8 out of the way. And in fact, when I distribute, looks like I'll have really 1/8 minus 3/8 cosine 2x plus 3/8 times that 1/2 1 plus cosine 4x. And then I have a minus here. I'm going to put it maybe down here. I have a minus 1/8 times that, cosine x, cosine squared 2x. So let's double check to see whether 1/8 got multiplied to everything. Here, 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 and minus 1/8 cosine cubed, which is cosine squared. Okay, it looks like we're okay. So there's a little more algebra to do, or a lot more, I should say. We get 1/8 minus 3/8 cosine of 2x plus, do the same move we did before. At this point, 3/8 gets multiplied to both terms, or I should say, not 3/8, 3/16, because we're going to also multiply 3, 1, 8, and 2 here. So we're going to have now 3/16 plus 3/16 cosine 4x, again, minus 1/8 cosine of x. Now might be a good time to replace your cosine squared 2x with what it's equivalent to by the half angle identity. And I'll write that portion in red. So that'll be 1/2 1 plus cosine of 4x. Okay. So let's see if we can figure this stuff out here, algebraically speaking. So since I'm on the topic, 3 times, sorry, not 3, but 2. 2 times 1, 2 times 8 gives me 16. So I'm going to be able to combine now. This is 2, and this is 16. I can add it with my 3/16. So this gives me 5/16 minus 3/8 cosine 2x plus 3/16 cosine 4x. Let's be careful here. I'm going to do this here in case you guys haven't noticed. I got a 1/2 factor there. I can pull that out, meaning I can multiply 1/2 times that negative 1/8. Put a middle step, I guess. That gives me negative 1/16 cosine of x gets multiplied to 1 plus cosine of my 4x. And now I can write this a lot better now. So I got 5/16 minus 3/8 cosine 2x plus 3/16 cosine 4x. This is going to give me a minus 1/16 cosine x minus 1/16 cosine of 4x. Okay, let's double check here. Cosine squared. Something doesn't seem right. Oh, yeah, something's wrong here. There we go. Something's wrong. Yeah, it didn't seem right at all. This term out here. Let's be careful here. Let's go back and double check here. You see, we're going to take this term and distribute. All right. Now, here we go. This is what happens here. We got minus 1/16. This now is going to be minus 1/16 cosine of x cosine 4x. Okay, now let's try to simplify everything that we have here. Okay, we might be able to combine some like terms, maybe not. We're going to see what we get. I get 5/16 now minus 1/16 cosine of x minus 3/8 cosine 2x plus, looks like 3/16 cosine x minus 1/16 cosine x cosine 4x. So we reduce these powers here. Let's double check. We forgot the 4x here. Okay. Let's double check everything. 5/16 minus 1/16 cosine x minus 3/8 cosine 2x plus 3/16 cosine 4x minus 1/16 cosine x cosine 4x. So double check here all the work. Okay, so as you guys know, we're supposed to integrate. In other words, I'm supposed to integrate this whole thing. And what happens now is I'm going to write this down here. You're going to get this. Let's kind of use properties of integration now. That'll be 5/16. Let's go back. My constant 5/16 I integrate with respect to dx minus 1/16, I integrate a cosine. And then I have a minus 3/8, I integrate a cosine 2x dx. Plus 3/16, I integrate a cosine 4x dx. And then minus 1/16, I integrate cosine x cosine 4x dx. So let's be careful. Okay. I have a first integral to do here. I have another integral here. These two integrals are very simple to do. If I integrate dx, that's just x. Since the derivative of sine is cosine, the integral of cosine is just a sine. So that one's nice and done too. Over here, I have u sub. And yes, u would be 2x. As you guys know, this answer becomes 1/2 sine 2x. So by using u sub here, focus on this integral here. This integral becomes 1/2 sine 2x. Integrating this integral over here, again by u sub. U substitution, u is 4x. I get 1/4 sine 4x. So these four integrals can be really easily determined. The last integral here opens the door to another video or another sort of lecture that we're going to have to know how to integrate here. This is what I'm talking about here. Let's focus on, this isn't an integral, but let's focus on what you see here. This is cosine x, and if we really want to be clear, let's do this. Cosine 4x. So let's focus again on this product. Now, what's going to happen here again is you're going to have to use, and I'll write this down, another identity. We have what's called here product to sum identities. So this is what we discussed in class, product to sum. There's a formula that we have for product to sum. So if we remember, this is cosine, if we say cosine A times cosine B. Now it might be better to use our parentheses here to describe this. I'll write this in red again. Cosine A, cosine B. Here's a product. That can be written as a sum. So cosine A, cosine B is 1/2 cosine of the difference of A and B plus cosine of the sum of A and B. So here's writing a product as a sum. What that means in our case, though, would be cosine x times cosine 4x becomes 1/2 cosine of x minus 4x plus cosine of x plus 4x. So now you have cosine x, cosine 4x is 1/2 cosine minus 3x plus cosine of 5x. And you're going to have to remember another idea here from trig. Okay, this is cosine of minus 3x. Remember something about cosine though. Cosine is a nice, I'll write it in red, even function. So you have a nice even function here. What that means is I could replace this with simply cosine of 3x. So this becomes, let's kind of keep it all here together, 1/2 cosine 3x plus, if I also distribute, cosine 5x. So I'm going to do both things. Okay, let's distribute the 1/2, and we're going to use the fact that cosine's an even function, so now it's cosine 3x. So the point I'm making here is, if you want to call this integral here, and you should, it's a separate integral that you have to do with an identity here, this particular integral up here, right? We're trying to integrate that integral. So let's get rid of these colors here. We'll keep this in perspective. This is the integral we have to integrate. Okay, so it's going to be this particular integral. So let's actually integrate that. That integral really becomes let's see, let's write every step. 1/2 cosine 3x plus 1/2 cosine of 5x dx. By properties of integration, 1/2 integral cosine 3x dx plus 1/2 integral cosine 5x dx. And again, we're going to do this by u sub. U sub. U here is 3x and u is 5x. So those integrals now become, let's replace these here. I have 1/2, and this will be times, maybe I'll keep it in red now, 1/3 sine 3x, maybe that helps people see things better, plus 1/2 times 1/5 sine 5x, which gives you 1/6 sine 3x plus 1/10 sine 5x. This is the integral that we replace here. So 1/6 sine 3x, let's go back. (1/6 sine 3x) plus 1/10 sine 5x. There you go. So let's see if we can see everything here now. Maybe I have to try to go back and highlight this. Let's say, okay, you got this term. These are all my integrals, my answers. And final answer here. All right, now we're going to have to be very careful to write this answer. But remember, you got some constants there. So I got this 5/16. Let's write down our final answer. 5/16. Let's go back. It's 5/16 x. See, be very careful. Did this answer. Minus 1/16 sine x. Got this answer. Be careful with your constants. You got a 1/2 here, and we got a minus 3/8. So that's minus 3/16. And what was that? Minus 3/16 sine of 2x. So let's pay attention to these constants. Plus 3/16 times 1/4 gives you 3/64. That'll be sine of 4x now. And let's be careful here. We have the minus 1/16 times 1/6. That gives you minus 1 over, looks like 96. sine 3x. And then you have the minus 1/16 times the, looks like it'll be 1/10, so that gives me minus 1 over 160. Sine of 5x. And so I just want to point out to you that sometimes people want to write this in sort of, if you look at the arguments, x, 2x, you got 4x and 3x, and then 5x. There's a sequence in there that's happening with the arguments x, 2x, 3x, 4x, 5x. Sometimes they want to reverse these two here. So I'll say these two terms can get reversed. So notice what that will be. Final answer. 5/16 x minus 1/16 sine x minus 3, and that's 16, 3/16 sine 2x minus 1 over 96 sine 3x plus 3 over 64 sine 4x minus 1. Now this last one here, I got to double check. I guess it is 1/10, so looks like it's minus 1 over 160 sine 5x. Don't forget to add your constant. So this is the kind of work you'd have to do in reducing your powers for power 6. Yeah. Now this problem here is very, very similar to if you had, for example, to integrate. Let's be careful here. This whole thing is the answer. So if you had, for example, let's make one up. Maybe I'll do something like this: sine to the 4th power of x cosine squared of x dx. It would behave exactly the same way, meaning you are going to have to, let's note, write your sine to the 4th as sine squared times sine squared, and then cosine squared. You're really going to have to again do this process known as reduce the what? Reduce the powers. So this is reducing powers, and you're going to use your appropriate identities. So 1/2 1 minus cosine 2x, 1/2 1 minus cosine 2x, 1/2 1 plus cosine 2x. So if you notice again, the powers here, they're even. 4, 2. You have even powers of sines and cosines again. You reduce your powers by what you did back in trigonometry, math 241. So algebraically speaking, again, I'm going to say you have 1/8 here, 1 minus cosine 2x, 1 minus cosine 2x, 1 plus cosine 2x. On the right side, we use FOIL. I'm going to start on the right. I think it makes your computation just a little easier. So I'm going to try to not talk so much and focus more on the algebra. So I'm just going to say FOIL. FOIL. distribute. Couple of interesting things to notice again. Power 2, power 3. Half angle identity for the cosine. It'll be 1/2, again 1 plus cosine double the 2x gives you 4x. This is going to be cosine again times cosine squared. So cosine times cosine squared. So let's kind of observe this is what we're handling at this point with identities, or at least the first one is a half angle. The second one is just using some algebra. Okay, and it gets hard to write this down really small. Okay. So I'm going to do some more algebra here. I'm going to talk less, work more. Half angle identity. Distributing right here. Now I'm going to have to do plus. Don't forget here there's a 1/8 cosine x times this whole thing. So that's going to give me, if I'm careful, the following. Let me be careful here. Let me write it a little bit to the right so we can fit everything in here. 1/16 cosine x plus 1/8 cosine x. Let's get rid of this. Cosine 2x. Okay, a couple of things to notice that we're going to have to do here. Arithmetic. Times 2 times 2. Second thing, product to sum. So let's write this down. 2/16 minus 1/16 gives you 1/16. I'm going to do another sort of thing here. I'm going to write this in, write my cosine first x there, and then I'm going to go with a higher. Minus 1/8 cosine 2x. So I dealt with my arithmetic. I have my cosine 2x minus 1/16 cosine 4x term. And now we're going to do the product to sum. So don't forget that's 1/8 times my product to sum here. 1/2 cosine x minus 2x plus cosine x plus 2x. Okay, so this is a product to sum identity here. This portion here is cosine minus x, and this is cosine of 3x. So let's do some distributive property here. That's 1/8 times 1/2. So let's write this down. 1/16. Notice what I also did. Cosine is even, so cosine minus x here is just cosine x. Okay. 1/16 plus 1/16 cosine of x minus 1/8 cosine 2x minus 1/16 cosine 4x plus 1/16 cosine x plus 1/16 cosine of 3x. So if we look at this, and I think, yeah, we can simplify here. 1/16 plus, looks like I'll get 1/8 cosine x here. This is what I'm talking about. 1/16 plus 1/16 for my cosine x is 2/16, which is 1/8. So, and then I have minus 1/8 cosine 2x plus 1/16 cosine 3x. Minus 1/16 cosine of 4x. 1/16 plus 1/8 cosine x minus 1/8 cosine 2x plus 1/16 cosine 3x minus 1/16 cosine 4x. Okay. Here's what I want to remark. All we did was reduce the powers. Okay? Reduce the powers. That's all we did. The integration part now is going to be, remember, we have to integrate all of this with respect to dx. So I'm going to do properties of integration as well. Integral 1/16 dx plus 1/8 cosine x. Don't forget to integrate that. Minus the integral of, and we forgot that 1/8. So let's bring that here. So it looks like we're going to have 1, 2, 3, 4, 5 integral problems to do here. Okay. Here's one. Didn't pull out the 1/8. Let's pull out the 1/8. Here's the second integral. My third, my fourth, and my fifth. X, sine x, u sub u is 2x, 1/2 sine 2x, u sub u is 3x, 1/3 sine 3x, u sub u is 4x, 1/4 sine 4x. And yes, there'll be plus a constant, so maybe I'll put that out here, plus your c. Let's take a look at what we really have as answers for integrals. X sine x, 1/2 sine 2x, 1/3 sine 3x, 1/4 sine 4x. Looks like I have 5 of them, so let's write our final answer here. 1/16 x plus 1/8 sine x minus 1/16 sine 2x. 16 times 3 is 48 plus 1/48 sine 3x minus 1/64 sine 4x plus c. And there you go. So this is what we do when we have even powers of sines and cosines. We just engage in that process called reducing powers here back in trigonometry, using these half-angle identities and then a product of sum if need be. This is kind of how you go about it. So, okay, I did want to make a couple of remarks here. So let me go back to a couple of these questions that we had, and let's go back to where we even started. 13, okay. Here's what I want to note. If they gave you cosine squared maybe of 2x dx, and sometimes people want to know what to do in that case, and I'll say here's really what I want to talk about it now is let me remind you of u sub. This will be my u, so now u becomes 2x, which means du is 2 dx, or dx will be du over 2. So here's what we're going to use. We're going to use u as 2x, and dx is du over 2. We're going to have to convert this integral in terms of x to u. So now this integral becomes cosine squared of u. My dx is really du over 2. So I will have 1/2 integral cosine squared of u du. So if you have I don't know, 2x there for u, using u sub, now you would go through the process that we did here, and you're going to replace this integral here. Let me maybe highlight that instead. You're going to replace that integral with what you had already found it to be. with this. 1/2, but it's going to be now 1/2 u. So this becomes 1/2 u plus 1/4 sine w. That is really 2u. And yes, you can say plus your constant, but you're going to have to go back to the work you did here. Okay, so this is kind of how you go about it. You convert it to by u sub. And so now, for example, this problem becomes replacing u with just the value that it is, or the term that it is. U is actually 2x. So this will be 2x. This will be 2x, but don't forget, the whole thing is multiplied by that 1/2 out here. So as a final answer for a u sub version of this, I'll put it in black. Looks like it's going to be 1/4 2x plus 1/8 sine 4x plus c, because you had to distribute here 1/2 to these terms here. Don't forget that 1/2 is outside. Yes, 1/4 times 2 becomes 1/2, so we can actually simplify that. So you'll have, looks like 1/2 x plus 1/8. Remember, 2 times 2x is 4x, sine 4x plus that constant. Sometimes people say, oh, can I write that as a half a constant? And, well, a half a constant is still a constant. Nevertheless, u sub is at play here. So there are a lot of problems that exist here with this in terms of u sub. I'd say you do the u sub first before you do the reducing powers. And that's kind of how you go about this. Anyway, let's look at another example and another note here. And I'll say, we'll put this note in purple. You have to integrate sine squared of maybe now x over 3 dx. Okay? This one is a u sub question with cosine squared. Now, this is another u sub question. I'll say here's u sub. U is x over 3. And that means du is 1/3 dx, or we say dx is really 3 what? Du. So, what that means is, this question now becomes, let me erase the work we already did here so people are familiar with all that work already. It's already in our notes. Just scroll back. I get now an integral, sine squared, well, let's go back here. This integral here in purple that we're talking about becomes the integral of sine squared u dx would be 3 du, and I pull out my constant 3. I now have to integrate sine squared u du. Let's get back our computer here. Okay. And so we might want to talk about what happens here with this u now. So u is x over 3. And so now I got 3 times, this is the answer here, but in terms of u. This here is the integral we got. Okay. So that integral is 1/2 now u minus 1/4 sine 2u plus that c. We did this question already. U again is, if we go back to find out what u is, right? We're going to replace this u. See, this u is x over 3. So that means I have x over 3. X over 3. So let's see what the final answer is going to be now. We got to be careful with the arithmetic. This gives us 1/2 x looks like. Double check. Minus 1/4 sine 2x over 3 plus that c now. Okay, let's get rid of this. We might want to see some algebra. Probably what people may want to double check with. Let's write down some more of the algebra in case you guys get a little confused here. Pay attention to kind of what's going on here with this. 3, 1/2, and time, that'll be 1, okay, x over 2 times 3 minus 1/4 sine of what? 2x over 3. Yes, it'll be plus c. So we're going to be careful with this. Be very careful here. See, we already kind of made a mistake, but this is what we're going to get. X over 2 minus, it was 3/4 sine 2x over 3 plus my c. So you do have some u sub versions of these questions, and this is what it comes out to. Okay, so I'll give you another example finally. We'll end with a u sub, maybe one that we haven't seen. We'll end with a nice simple one. They go maybe, let's try this. Sine squared pi x dx. U sub u is pi x, du is pi dx, dx is du over pi. So here's what I end up with. The integral of sine squared u du over pi, which is 1 over pi integral sine squared u du. This is what we need to integrate. Half angle identity. 1/2 1 minus cosine 2u. So 1 over pi integral 1/2 1 minus cosine 2u du. 1 over 2 pi integral 1 minus cosine 2u du. One over 2 pi u. Oh, another u sub, different u though. Can't call it u. Call it t sub. T sub. T is 2u. dt 2 du. du dt over 2. So maybe we'll do some details here. One over your 2 pi integral du minus 1 over 2 pi integral cosine 2u du. This integral is what we're focusing on. This one becomes simply u. This is where the t sub comes in. So this integral becomes cosine t dt over 2. 1/2 integral cosine t dt. That's 1/2 sine t, or 1/2 sine t is 2u. Right over here, t. Okay. Bring everything down. 1 over 2 pi times u minus 1 over 2 pi. This integral was 1/2 sine 2u. Don't forget to add your c. So when I reduce here, this is 2 pi u minus 1 over 4 pi sine 2u plus c. Now remember, what was u to begin with? U, all the way back here, is pi over x. So I'm going to place my u with a pi over x. Or pi x, sorry. Pi x. Pi x. Final answer. X over 2 minus 1 over 4 pi sine 4 pi x plus c. So here's a u sub version of some of these integrals as well. So I wanted to remind people about some u sub. And this is how we integrate a sine squared pi x problem here.